Hi, all you cute cat and kittens out there. It's Miss Ducey with our new physical science classroom lesson today. So you should have these pieces of paper out in front of you from your take-home packet. You see on the left, we only have 2 slides of notes we're going to go through, and on the right is an activity that you're going to be completing for class today. So I'd like to start out with our question of the day, warm up our brains, start thinking about science a little bit, and we're going to review over some of the terms that we learned in our lesson when you last connected with me, in which that lesson was about what's an anion, a cation, and Lewis dot structures. So if you could pause this video, take a moment to work through the question of the day, and warm up your brain before we finish the rest of this lecture. So this first section is a matching section. So we're going to match an anion with D, a negatively charged particle. A cation is B, a positively charged particle. Group 2 would consist of C, a group of positively charged particles, and group 17 would be A, a group of negatively charged particles. Now I asked you to draw the Lewis dot structures for aluminum and arsenic, and I also wanted you to label them with the oxidation numbers associated with each. So for aluminum, you see that there's 3 valence electrons all evenly spread out around the element symbol, and we have an oxidation number of +3. For arsenic, our element symbol is As, and we put all of our valence electrons, 5 of them evenly spread out. Only one of them is pairing because we have to fill in the 4 places first. Then we add that 5th one to the left there, and we also write in our oxidation number of -3. These would actually make a perfect pair coming together. You wouldn't need multiples of either of them. They would be a perfect bond, a cation and an anion, because together they would make a neutral charge of 0. We're going to learn about 2 different types of bonds today. There's one called an ionic bond, and there's one called a covalent bond. Now, if you ever take chemistry, you're going to go really deep into these topics. We're just brushing the surface, helping you become familiar with that terminology. So an ionic bond is a bond where electrons are being given away to one another. They're actually getting rid of the electron and giving it away. So for example, you have sodium and chlorine. Sodium has an oxidation number of +1, chlorine has an oxidation number of -1. We've given this example many times in class, but in order to create a bond, sodium is going to give away one of its electrons to chlorine so that sodium can have completely filled outer energy levels and chlorine can have completely filled outer energy levels. Versus a covalent bond is a bond where electrons are shared between atoms. An example of this is water. Water consists of hydrogen, 2 of them, and an oxygen. Now those hydrogens, they only have 1 electron, and they don't want to just give it away to oxygen, they want to share with it. So you can see kind of the difference between these 2 diagrams. For hydrogen, they're hugging the same electrons together, they're sharing them, they're being very kind, versus for sodium and chlorine, sodium's just giving an electron away. So in summary, ionic bonds give away while covalent bonds share. So today you're going to be working on an activity. If you pull this out, and it's called Water, the Mickey Mouse Molecule. I'm going to read this introduction to you. Water droplets are round, but if you kept dividing one into smaller and smaller pieces, what would an individual molecule look like? Water, like all matter, is made of tiny particles called atoms. Atoms are made up of protons, which have a positively charged, electrons, which have a negative charge, and neutrons, which have no charge. Protons and neutrons are located in the center, or nucleus, of the atom, while electrons spin around the outside of the nucleus. Electrons are organized in energy levels. The closest level to the nucleus is only able to hold 2 electrons. The next level can hold 8. When a bond forms between two hydrogens and one oxygen to form a water molecule, a sharing of electrons occurs between the hydrogens and the oxygen. This sharing fills the first and only energy level in each of the hydrogen atoms, as well as the second energy level in the oxygen atom. Because both hydrogens are located near to one end of the oxygen, and their protons are nearest that end of the molecule, that end tends to be positively charged. The other end is negatively charged. This causes the water molecule to be called a polar molecule and results in the strong attractive forces between water molecules because opposite charges attract. So this is what you're going to do today. From the following page 64, this one, where you see these cutouts for a molecule, you are going to cut out all the atoms, protons, neutrons, and electrons, and you're going to assemble a water molecule from those cutout pieces so that it resembles this diagram that's on the sheet of paper. When you're done, you're not going to be able to attach it to a classmate's, but I still want you to think about how would multiples of these water molecules attach together, thinking that the same rule applies that opposites attract, positive and negative being opposite. I want you to think about which side of this is more positive, which side is more negative, and where is it going to attach to. So you're going to cut all these out, do this on your own, and you're going to take a picture of your, going to insert the picture of your Mickey Mouse molecule into the Google Drive document today. So you get this document by going through Schoology. You see water in the Mickey Mouse molecule. It's an assignment. You're going to click on it. It'll open up this separate Google document for you. First thing is you should put your own name in the left-hand corner. Insert an image of your Mickey Mouse water molecule here. And then instead of handwriting the questions, I want you to type answers to these questions in your own words and complete sentences, and go ahead and type them directly into this Google document. So if you were answering this one, I might say my answer is here. I'm going to type them directly right beneath where the question is. And then there's directions below in case you have any complications submitting this assignment to Schoology. Other than that, that is your assignment for today. You should work on that, answering your questions, and go ahead and get this turned in. Thanks, guys.